Alright guys and gals, the purpose of this lab is checking net cooling capacity. I've had the condensing unit running for about 15 minutes now, so everything should be stable. A couple quick measurements, all we need to take without hooking up any gauges at all. So the first thing we need to do is measure the air entering the condenser. You want to make sure that all the coils are clean, your air filter is clean whenever you do this test. So we're going to measure the air coming into the condenser. Then we're going to measure the average air leaving the condenser. When I say average air, you want to take multiple measurements depending on where your thermometer is. The temperatures could be different. So you're going to measure it here, write down what you got, measure it here, write down what you got, here, what you got. And then as we take an average, we add all those up and divide it by the number of measurements taken, we'll get an average. I've already done all these numbers because we're running out of daylight, so. But again, we take our entering air into the condenser, our average leaving air of the condenser. Test instrument I'm using is a Fluke 971. It's a good meter. So once we got that, we come over here. We need to measure our voltage. Going in, got 242, and then the total amperage, 6.3. So I'm taking that amp draw on the line coming in, and I'm taking that voltage measurement on the line coming in. So that's total condensing unit amperage. We want our fan motor as well as our compressor, all of it. So let's see what we got. Never mind the mini vac.
Didn't even show it.
So here we need to know some data. This is the data I got from that condensing unit. What we're interested in is the fan CFM. So our outdoor fan motor CFM is 1425. We need to know that number to do this test. So here's our worksheet example. First thing we need to know is our fan CFM. It's 1425. We got from the manufacturer. The second thing we need to know is average the condenser air leaving. I averaged it at 68.4. We need to measure the air entering. I measured at 55. That delta T, all that is the difference between the two, 13.4. Our total amperage, when I did this test, it was 6.4 amps. Our voltage, I measured 241.4. We're going to round this to the 10th. And then we just got a little bit of math. So, and this worksheet breaks it down for us. So our amps times volts times our power factor, we just use 95 as a constant. I came up with 1467.7 watts. Okay, and all that is amp times volts times the power factor. We got our watts. Now we need to figure our BTUs. So we're going to take that wattage times 3.41, hopefully everybody knows by now, to come up with BTUs. And I rounded that to the nearest whole. So that's telling me I've got 5,000, a little over 5,000 BTUs of heat just in my compressor motor and my outdoor fan motor. Most of that's compressor motor. Okay? So we're going to apply the following formula. You guys all know this, the sensible heat formula. Everything we're doing with the condensing unit is all sensible heat. We're not changing the humidity at all. We're just rejecting all the sensible and latent heat from the evaporator. We're rejecting it all sensible into the atmosphere in the ambient conditions. So we're going to use the 1.08 times CFM times delta T. 1.08 is always a constant. That's our specific heat BTU. And our air density at sea level, that's where, going back, oh God, probably about 10 weeks now, that's where that number comes from. So we got our constant times our CFM, which we get from a manufacturer on line 1, 1425. That's our CFM of our outdoor fan motor, times our delta T, which we measured is the condenser split, some call it. It's a temp difference of the air in the condenser. We said 13.4. We came up with 20,623 BTUs. Then we need to subtract our motor heat from that, and we come up with 15,618 BTUs. And this is a 2-ton condenser, so that tells me I'm probably going to be hooking up gauges and making sure my pressures are good. This is just an old condensing unit. It's from 1996 that air conditions a shop, so it's not a really crucial piece of equipment, but at the same time, I should be a lot closer to 24,000 BTUs than that. I'm a little bit better than half, so I'm definitely low on capacity. And again, if you guys look at the temperatures, it's 55 degrees outside, so in the real world, we should be shooting for, when we do this test, at least 65 outside. But just to give you guys an example of checking the net cooling capacity, just by measuring some temperatures. If you've got a thermometer and you've got an amp clamp voltmeter, you can come with, and a little bit of math, you can come up with a guesstimation of how much cooling capacity your condensing unit is producing.